All right, so what we were looking at before, I didn't put this up there. These are some properties of the dot product. We looked at them in earlier videos, all right? You remember, if you didn't see those videos, you should check them out. So we look at these in earlier videos. Now, theorem. This is a theorem of the dot product, and it involves an angle. If theta, this is an angle, right? You know, this is a Greek letter. It's a popular letter to be used to represent angles. If theta is the angle between two non-zero vectors, well, it's either 0 or not 0, so it's non-zero. It's not a vector that is 0. If it's 0, you can't even see it. If theta is the angle between two non-zero vectors, u and v, then u dot v would be the magnitude of u times the magnitude of v cos theta. So that is a theorem. Alright? But before we do anything else, let us see how this thing goes. If we have these two vectors, let's say this is u and this is v. You remember the triangle law of vector? This here would be the resultant, right? If you have u coming down, or let's say the resultant is going up there. If this is v and this is u, you remember that when you add the two vectors, they must follow each other around the triangle and must oppose the resultant, alright? Now, suppose you have a case where you have a situation like this. Both vectors are leaving a certain point. Then what you're doing is saying u plus negative v, which is u minus v, right? That's what you're really doing. Because you turn v around in the opposite direction. So you're saying u plus negative v, where negative v is the inverse vector of v. Now the thing is, this is the angle theta. Now, here, you remember your cosine rule? What it says is that this side, if you're finding this side, or by the way, let me write it generally first. It's saying a squared equal b squared plus c squared minus 2bc cos a. Alright? Oh, cos angle A, big A. This is on your CSEC formula sheet. CSEC maths formula sheet. And elsewhere too. It says, if this is A, this length A squared equals this length BC squared plus C squared minus 2BC cosine of this angle. Alright? Remember that. Now, here, this vector is u plus negative v, which is u minus v. Alright? So that's what you have there. You see? So, we're just examining this theorem, right? And looking closely at it. The magnitude of u minus v squared, this would be like the a squared, right? Equal u squared. This u squared is like b squared, alright? Plus v squared is the magnitude, right? the magnitude of the vector squared. And this is our v squared, would be like the c squared, minus 2 times u. Right, let's just write it, u, magnitude of u, times the magnitude of v, cosine of the angle theta. See that? So now, let us look at this property here. U dot u means the magnitude of u squared. So the magnitude of u squared is u dot u. Therefore, by the same argument, the magnitude of u dot v squared should be u dot v. Alright? So the magnitude of u minus v squared is supposed to be u dot v no, I'm mixing it up. The vector is u minus v. The vector I'm using is u minus v. So u minus v is a vector. Alright, the magnitude of the vector u minus v squared is the vector u minus v dot, I put it in bracket, u minus v. Alright? Now the thing is, u minus v dot u minus v, in that case, right? Just like when you multiply out two things in bracket, this is u dot u plus u dot negative v. Now remember, don't mix this up. These are not horizontal and vertical components we're doing. We're not multiplying horizontal and vertical. We have two different vectors and we're dotting them. Alright? So it's u dot v. So plus u dot negative v. Let me put the negative. Plus negative v dot u negative v dot u. Let me put these in bracket, by the way. Plus negative v dot negative v. Negative v dot negative v. You see. Alright. So it is equal to. Now, let's rewrite it. U dot u minus u dot v minus v dot u is the same as u dot v. Alright? Remember the property up here. U dot v same as v dot u. Alright? Plus v dot v. So you see. Alright. Now, the thing is, this part is same as u dot u minus 2 u dot v plus v dot v. Alright? So you see that? Now, let's look up here. See what's going on. When we look up here, we see that u dot u is the same as u, the magnitude of u squared. So this u dot u business here is same as magnitude of u squared. Right, this is minus u minus 2 u dot v plus this is the magnitude of v squared. So that is u minus v squared. All right. Hold on. Let's see what happened here. So this and this, they are the same thing, right? See that? Same thing. Now, look at this. This and this. What happened here? Must be the same thing. You don't see that? All right. You see it. So you see. Suppose you equate them now. And you say, this you have right to so is u magnitude of u squared minus 2u dot v plus v magnitude of v squared is equal to u magnitude of u squared plus magnitude of v squared minus 2 magnitude of u magnitude of v cos theta. Now, what do? You consider magnitude of u and magnitude of u. Subtract them from both sides. Right? This will go. Magnitude of v and magnitude of v, subtract them from both sides. This will go. So you have negative 2 u dot v equals negative 2 u magnitude of u magnitude of v. Alright, we'll break at this time and continue in the next video. No, we won't need to break. I thought we were out of time. We all want to keep the video below 15 minutes. So this is cos theta. So if you divide both sides by negative 2, that will go. So what you have is u dot v equal magnitude of u magnitude of v cos theta. So u dot v is magnitude of u magnitude of v cos theta. So there you go, the theorem.